Okay, पुढे
हे पहा
दिसतं.
टाइम सुरू झाला.
Okay,
टाइम सुरू झाला म्हणजे ऑन झालं.
okay. Now we can discuss today about the determinate and indeterminate structures. First of all, we'll try to discuss something about the types of supports. We'll discuss first of all about the simple supports, which has got one reaction vertical on this side. Secondly, then we'll go for the second type of support, then we call the hinge support. It has got two types of reaction, one is the vertical and another is the horizontal. It won't take a moment at all because it is a hinge and it will slip if the moment is applied. Third type of support we can call as the roller support, which only offers vertical and horizontal reaction is not there. So only one vertical. When we are talking something about the hinge, there are two reactions. When we are talking about the simple support, there is only one vertical reaction. Fourth one rather, there are fixed support. It has got three reactions: one vertical, other horizontal, and third the moment which is coming over here. Now we have come across all four types of uh, supports, and accordingly how much reaction that is developed. I will repeat once again, summarizing: simple support, one reaction; hinge support, two reactions; then roller support, one reaction; fixed supports, three reactions. Now, there are three general conditions of equilibrium, we know very well. It is sigma h is equal to 0, sigma v is equal to 0, and finally sigma m is equal to 0. If the number of support reactions are less than or equal to the number of equilibrium conditions, such structure is known as determinate structure. If number of support reactions are greater than number of equilibrium conditions, then such structure is known as indeterminate structure. Now we'll take some examples and we'll see whether it is a determinate structure or indeterminate structure. First of all, we are taking a simple beam with one end simple support and other hinge support. When dot is there, that indicates it has got a hinge. Now, we have already seen in our previous statement that when there is a hinge, there are two reactions, 1 and 2, and simple support there is one vertical reaction only. So, total number of reactions are 1 plus 2, that is 3. And how many equilibrium conditions are there? 3. Now we can see when this is equal to this, means these reactions are equal to the number of equilibrium conditions, then we can say yes, this is a determinate structure. Now we'll go for the next part, next example, that is one end is hinge and other is on roller. Again, as usual, we know that equilibrium conditions are 3. Now, when it is hinge, there are two reactions, 1 and 2. And roller, again it is 1, only vertical. So 2 plus 1, that is 3. Equilibrium conditions are also equal to 3. So we can call this as a determinate structure. Now I am taking a cantilever, which one end fixed and other end is free. When we are talking of such type of beam, then there are only three reactions that we have already seen. One is the vertical, another is the horizontal, and third is the moment. So there are total three reactions and three general conditions of equilibrium. So again it is this is equal to this. So we can call this as a determinate structure. We'll go for the next simple example. Both the ends are hinged. This and this. Both the ends are hinged. Now, when it is hinged, it has got vertical reaction as well as horizontal reaction. This is also hinged. This is again a vertical reaction and a horizontal reaction. Total reactions 2 here, that is 4. Equilibrium conditions are 3. So, it is indeterminate structure of 4 minus 3, that is 1 degree of freedom. Now we will go for another example. Example itself will show how we can define the determinate and the indeterminate structure. Now this is a propped cantilever which is fixed at one end and hinged at the other. Now here when we talk the propped cantilever, now again we have seen when it is fixed, there are 3 types of reactions. One, vertical, horizontal and moment. Hinge, there are 2 reactions, one vertical, other horizontal. Total reaction, it is sum of the 2, that is 5. Equilibrium conditions are 3. So it is 5 is greater than 3 by 2 numbers, hence it is indeterminate for the 2 degrees of freedom. Similarly, when we talk of this fixed beam, this is fixed over here, this is fixed over here. And as we have already seen, when there is fixity, it has got 3 reactions, 1, 2 and 3. Here also 1, 2 and 3. And the total reactions comes out to be 3, 6. Equilibrium conditions are 3. So the number comes out to be 3. So it is indeterminate structure for redundancy of 3 only. This is one part about the beam. Then we go for the next part of this, is a truss. When we talk of the truss, then we have a simple truss. One thing is there. When we are talking about this truss, all these are supposed to be connected to each other but not rigid. It is not a rigid joint. So now when we talk of this truss, we are taking 3 members at a time with the 2 supports. Here again, this is a hinge and this is a simple support. But it is slightly different than that of the beam. In beams, we have got only one equation to solve the determinacy or indeterminacy. But in a truss, there are 2 types of concept that is to be taken into consideration. One is the internal determinacy and other is the external determinacy. So when we are talking about the external determinacy, we have to deal with that 2 reactions and equilibrium conditions. And when we are talking about the internal redundancy, then we have to think about the number of members and the number of joints. We will see one after another. Number of joints are 3, 1, 2 and 3. Number of members are 3, 1, 2 and 3, already given the numbers so far. Now external redundancy can be found out by one method. To this add the internal redundancy, that will give the total redundancy of a truss. Now DE is called the external redundancy. As we are doing in the case of the beam, we are only talking about the reactions. When we are talking about one is simple support and other is hinge, so it has got 2 reactions, it has got 1 reaction, the total reaction comes out to be 3. But when we are talking about the internal redundancy, one mathematical expression is there, M is equal to 2j minus 3. 2j minus j stands for number of joints and M stands for number of members. Considering now this same figure, number of joints are 1, 2, 3, 2j, 2 into 3 that is 6, minus number of members that is 3, it comes out to be 3. So members will be 3. If members are equal to 2j minus 3, then we can say yes, this is internally determinate. And hence we can say internally determinate is 3 equal to m is equal to 3, 2j minus 3 is equal to 3, so it comes out to be determinate in all respects. Now I am talking something about continuous truss like this, having number of panels which is taken into consideration. When we are talking about the number of trusses over there, then here again I am taking the 2 supports. And number of panels are given 1, 2 and 3 panels. With whatever height it will be, we are less concerned with the height and the loading. We are only confining ourselves for the support reactions, types of supports, number of joints and number of members. First of all, we as usual go with the external redundancy, that is concerned with the number of reactions. So we talk of the number of reactions. Then we find here again when it is hinged, there are 2 reactions, roller support, 1 reaction, total external redundancy comes out to be 3, 1 plus 2 plus 3, and equilibrium conditions are also 3. So externally there is no redundancy so far. Now sir, internal redundancy can be seen by considering only number of joints and number of members. Let us see how many number of joints are there. 1, 2, 3, 4, 5, 6 and 7. Total number of joints are 7. 2j minus 3, 2 into 7 minus 3, that is 14 minus 3, that is 11, must be equal to number of members. And we have seen, we have already given the number of members as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Here, that clearly indicates that the number of members is just equal to 2j minus 3. Hence, this is also a determinate structure. Now we will go for the next part, that is this type of structure. Again, this is a truss. Now the members are again Amalfi. These are the 2 reactions. Here it offers 2 reactions. Here it offers 1 reaction, and the total reactions comes out to be 3. And we can say externally it is just redundant. Now let us talk something about the number of joints and number of members. When we talk of number of joints and number of members, then we find that joints 1, 2, 3, 4, 5, 6, 7 and 8. 8 joints are there, means 8 to the 16 minus 3, that is 13. We must need 13 members for internal redundancy. Let us count the number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. I have committed some mistake over there. 8, 9, then it will be 10, 11, 12, 13 and 14. It should be 14 like this. So total number of 14, but we want only 11. So this is the indeterminacy for 2 degrees, and hence total will be 5, and that comes out to be indeterminate for 2 degrees of freedom. I am talking now the last part of the truss.